So like for large n equal to 9 and then k equal to some 10,000 something. So I was just doing brute force, but I see there is
brute force is not a problem. Brute force will be a problem. Brute force, if you do all the combinations and then find out and then do it, it's a pain. See, if you look at the question, right, I thought of the same thing. Okay, let's do the question number 31 is, if you have like 1, 2, 3, 4, 5, 6, and the numbers are, let's say we are given with 6, 4, 5. Yes, 3 and okay. So what's the next number out here? So the original list of numbers is 1, 2, 3, 4, 5, 6. This is the current sequence. What is the next sequence? Right? So next sequence is, if you look at it, you need to change 1, 2, will remain the same, but the change will be 3. 3 will be changed to 4. And then the rest will be 5, 6. Sorted.
yeah.
So the question becomes, first part becomes find first number with, no, I think we did something wrong here, which is not, this is not the right, this is, has to be, let's say this was 5, 4. Yes, so that will be, this will be 3, 4, 4, then, yes.
1, 2, 3, 5, 4, 6.
The next sequence is, and hold on, next sequence is hash 1, 2, 4, 3, 5, 6, right? No, 5, 5, 6, yes. You can't change anything else than that. Okay? Looks okay or no?
Yeah.
So there are two operations here. First operation you're looking is, change 3 to 4, which means find first two elements or pair where left is smaller than right. So that becomes to be 3, 6. So that it gives you, we need to change 3. Second operation is change 3 with smallest number bigger than 3 on the right of 3. So that becomes 4. So the sequence becomes 1, 2, 4, 6, 5, 3. Third operation is sort the right part, which is 6, 5, 3. So what we are doing is going from the right to the left. We look at the number which has decreasing, and say 3 is the one will change. So we have to change 3.
So Ankur, we need to swap here or we need to simply change it with something
Swap.
else?
First swap it.
Okay.
So this is a swap operation. So first thing is we find the 3, then we swap it with the swap 3 with a small number bigger than 3, but on the right hand side, smallest number bigger than 3 on the right of side, on the right of 3, okay, which is 4.
If you look at the current sequence, line number 11, so 2 is less than 3, 1 is less than 2. So why did you choose 3 and 6?
No, on the right hand side of 3. So
No, why did we choose from 3? Why not some other digit?
see, you can't change 1, 6, 4, 5. See, what is after 6? So next number is you increase more than 1 here, right? So it was it was like 4, 5, right? Next number is 5, 4. Okay. So we can change. So we have to look at what's the next possibility of increasing the number. Next possibility of increasing the number is when you are replacing the smaller number by bigger number. So we are looking at a number which can be replaced by which is less than the right number. So if you look at the sequence here, hash 1, 2, 3. Let's go back to the paste here. So what's the next number here? So we are saying next number will be 1 will remain the same, but these numbers will be 3 and 2, right?
Yes.
So we can extend it to, let's say this was something like this over here, or maybe just leave it. Similarly, we are saying let's do it as 1, 1, 2, 3, 3, 3, 1, 2. So again, the problem becomes that we are changing 1 and 2 here, and this becomes /2 and /1. Let's say one we have, next one will be, we can't change 1, now we can't change 2, we can't change 3. So the problem becomes we need to change hash 1 becomes 1, 2, 1, 3, then you need to sort the other ones 1, 2, 2. So we change the position. We change this position, right? Here we change this position. So what's the common thing between them? Left side is smaller than the bigger right side, right? And sorry, we change not this one, we change this one. Okay. So the operations become, the first operation is find the position which you need to change, which is always the number where it is decreasing than the right hand side, which is 1 and 2. And what do we need to change it with? We need to change it with a big number which is on the right side, but is bigger than the myself, but less than it's the smallest one. So we find the number here, we change it with the number, that's number with 2, and we change it, and then we got a number, we change 3. So let's say this was the first operation. Let's say we have to change 2, we change 3. This becomes, let's say the first step is undo. We change 2, 2, 1. First step. Then we do is we sort this out. Then becomes 1, 2, 1, 2, 2. And this becomes this is the question becomes how you're solving it. Got the idea?
Yeah.
So first thing, see, always when you're incrementing, you have to increase one number, right? So which one we need to increase? The one which is, so that if you look at the numbers, if you are increasing the numbers from 1 to 132, we will look at the number which is smaller than the right side. We just increase that 2 to 3. Then on the right, everything becomes sorted. That's the main part.
So the example, second example, 3 to 1 to 1
Yeah.
to 3.
So there's nothing over there. So the index becomes that I'm negative. So sort everything, the whole order. My first part here, when you're trying to find the sequence,
Yeah.
find the position that will be -1, then sort everything out. Okay?
Okay. Okay, thanks. I'll try this out.
So if you look at let's try some question here, step 1 by step 2. So first thing is edge case. If not nums, if then nums is less than 2, return nums. My test case failed because of this. If it is like empty or 1, you can't do anything. It will be same always, right? So this is first part. So first operation is find the number which is less than that. Okay, so find position equal to -1. Yes, position equal to 0. Let's say 0 for I in range 0 to, let's say, n equal to n of nums, we say n minus 2, n minus 2 because we compare with n minus 2 comma n minus 1. So if nums of I is less than nums of I plus 1, we say position equal to I, break, else we say 0 to, we don't need to, while I range of, no, we have to reverse from the other side, sorry. While I has to be len of nums minus 2, while I is greater than 0. Otherwise, we say minus equal to 1. We're doing from the reverse side. We're looking from the RHS, not from the LHS, so we can't do for loop. We have to do the from the right hand side. So let's see. Print position. Let's run this test case and what happens here. Run code. Indentation error is somewhere here. Yep, run code.
We need to do I-1 and I in the comparison.
Where?
On the line number 42, nums I-1 is less than I. I-1 index if it is less than index I.
No, we need to see that I, the one I'm looking at, is less than the number I plus 1, then we break it.
Yeah, but in line 40, I is line -1. So I plus 1 will go out.
So 2. Sorry. It's 2.
Okay. Yeah, now.
Sorry,
Yes.
that makes sense. So this is 1, 2, 3. We're saying we need to change position number, this one. Okay. Let's change the position. We say number is, let's say 3, 6, 5. So this will go to run code 0, 1, 2, 0, 1, 2. You have to change 3 here. Okay.
Okay.
Which is position number 2. Print position, and we say comma nums of position. So the value at 3, we have to change it to 3. Okay. So this is first part. So what we need to change with?
The next number that is greater than 3. The next smallest number greater than 3.
For max val max position equal to sys dot max size, comma sys dot max size, max val for I in range position plus 1 to n minus 1. N minus 1, we say if or n minus n, not n minus 1, this will be already n, position n. If we say if nums of I is greater than nums of position, if nums of I is less than max val equal to nums of I, and max position equal to which is I, and you print the value, print max val max position. So this should say I went from position 1 to n, which is starting from next position, go to the end. If number is of I is greater than my position, which is we got from last time, and it is less than the max val, then change the max val. So next comparison can be compared here, and we change the position to this thing. Yes. So we are changing the position 4, which is value 5. X position. Oh, hold on. Maxwell is okay. Maxwell is 4. Value is 4. Let me do it another way. Same way. Maxwell. So it's saying that change the value with the value 4. Okay. And you are saying, let's do this one also, put it correctly here. We say position nums of pos. So you're saying we have to change value 3 with value 4. Fine. So now we do the swap. We say swap is nums of position, nums of max pos, equal to nums of max pause. Python allows you to write in a single line, multiple this thing, nums of pause. So print nums. So we solved it. Let's run the code and see what happens. So we came 124 and the rest of them are 653, right?
Yeah.
So now
Sorry.
sort it. We say nums of
Pause.
4 plus 1 colon to n equal to sorted nums of pause plus 1. I think I can write a smaller way, but let's find n print nums. So we got 1, 2, 3, 5, 6, 1, 2, 4, 3, 5, 6 accepted, right?
Cool.
I hope this is correct. I don't know if it passes all the test cases. Let's see. Something went wrong here. What's the value? Oh, 1 and 1. Okay. Edge case is 1 and 1. Okay. If everything is same, that's a problem.
Yeah.
If
I
every-
think that's okay. This is just an edge case.
yeah, I think for interview is okay, but at least figure out that if okay, if or len set nums equal to 1. Let's see if it makes it pass or not. Actually, I can do it later on also, but this is just, let me see if it works. This is saying that if everything is same, just return nums, right? I made a set. Set is like unique values. Then the number of unique values. If it is 1, just return 1. What the heck? 3 to 1. Did I do something wrong?
So 3 to 1 cannot be changed, right? So
No, you have to change to 1 to 3. You will change 1 to 3. Then you say, hold up. Let me do one thing. I think this is the problem. My problem is if it is max size, if max position equal to sys dot max size, max size non is equal to sorted nums. Oh, just to make a new variable. That doesn't make sense. You need to change it in place, which is how do you do the sorted off? This is correct, but
So you can say nums dot sort.
what is it?
Nums dot sort.
Okay, nums dot, yeah, that I can do. Yeah, dot sort. Okay. Run code is okay. Run code is fine. Yes, thank you.